and welcome to the mathleague YouTube channel. The following video was recorded by one of our staff members live at one of our contests.
I am back to share another problem with you. This time we are going through number 9 on our team round. So the problem reads, a token is placed on one of the 3 squares in the diagram below. Every minute, the token is moved either 1 square clockwise or 1 square counterclockwise, with each direction being equally likely. What is the probability that after 3 moves or after 4 moves, the token is at the square where it was initially placed? Express your answer as a common fraction. So to start, I'm just going to go ahead and label these squares A, B, and C, and I'm going to arbitrarily say that we start at A, just to make things a little bit easier to visualize. So since every minute the token moves either 1 square clockwise or counterclockwise, we can't have it that after 3 or 4 moves, the token is on A for both the 3rd move and the 4th move, right? If it's at A on move 3, it's either got to move to B or it's got to move to C. So there's no overlap in these cases. So let's do some casework. Let's start with 3 moves. If there are 3 moves, then there's a total of 2 times 2 times 2 for 8 possible paths of 3 moves. Because after each move, the token can either move to square B or square C for the first move, and then so on and so forth. So 8 total possible paths. And let's count the number of paths that end back at A. So on our first move, we can move from either A to B or A to C. And then once it's over at one of B or C, it can't go back to A, because then if it's on A after 2 moves, it can't go to A at 3. So then it's got to move to the other square that isn't A, and then on the 3rd move back to A. So there's a total of 2 possible paths, either a counterclockwise circle or a clockwise circle, that end back at A, and there are no other possibilities. So 2 successful paths out of 8 simplifies down to 1/4 chance that the token is at A after 3 moves. Now let's move to the case where the token ends up back on A after 4 moves. And we might be looking at that thinking, well, there's so many possible cases. How are we going to count them all? But there's a shortcut here, because we already know that the probability that the token is at A after 3 moves is 1/4. And either it's at A at the 3rd move, or it's not at A after the 3rd move. And obviously, if it's at A after 3 moves, it can't end up at A after 4 moves, right? So it's got to be at either B or C after 3 moves to be able to move to A on the 4th move. If it's at A for the 3rd move, it can't be at A for the 4th move. But if it isn't at A, all of those cases could end with it at A after the 4th move. So there is a 1 minus 1/4 chance, which is 3/4 chance, that it's not at A after the 3rd move, aka it's at B or it's at C. And then no matter which of those 2 squares it's in, the token moves back to A with a probability of 1/2, because either direction is equally likely. So we multiply this 3/4 by 1/2 to get a 3/8 chance that the token is at A after 4 moves. And then we just add those 2 possibilities together. So adding those together, we get 1/4 plus 3/8 equals 5/8 is our probability that the token ends up at the square where it started after 3 or 4 moves. And we are done.
Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.